class. I guess you get to see me even though I'm not here. What I would like to do today is to give you a few examples of what we're doing again, because I know over the weekend we get out the cobwebs and we forget. So I'm going to give you a couple examples, and then I'm going to show you a kind of the opposite way of what we've been doing. So the first example that I want to give you is to write the chemical formula for chlorine 6 phosphate, or chromium 6 phosphate. Okay, first things first that we talked about was we have to look up what the charge is of chromium, but luckily we have a Roman numeral, so it already tells us. What's the charge on it, everyone? 6. So we have a +6 on this side, and then we have to look up what the charge is of phosphate. Now I hope that you are noticing that the ending is not an IDE, so our job is easy. All we have to do is look at our chart. Now, if you want some more of these charts that you didn't take, I have some up on the table here for you, so come and grab it. We look at what the charge is for phosphate, and again, you look at your handy dandy little sheet, and when you look up what phosphate is, it's a polyatomic ion. It's made of more than one element, and it is PO4 with a 3- charge. Now, remember what I talked about. This PO4, this is phosphate. We cannot change it. If you change this subscript or add a subscript here, it is not phosphate anymore. You have to keep this intact. If you add a subscript to phosphate, it has to go in parentheses and on the outside. But now we have our charges down, and we have to figure out what the chemical formula is. So chromium, we have a Cr +6. We have a phosphate PO4 with a 3-. Our little handy dandy trick was to crisscross our charges. So our 6 would go down here, our 3 would go down here, and I would have Cr3 PO4 6. But I hope you're all screaming in your head, Mrs. Miller, that's wrong, because you would be right. We need to reduce this, and that means a 3 can go into 3 and to 6. So it would be Cr PO4 2. And this is your final answer. Now again, if I went a little bit fast, just go through the video and watch it again. That's what's kind of nice about it. This is what we've been doing all last week, so I feel like that you should be pretty good with, just to give you a little bit of review. And just remember this little Roman numeral. It makes your life a lot easier because it tells you what the charge is on that metal. And these are only transition metals. Okay, I'm going to erase it so we can go on to the next one. Now today, what you're going to work on is looking at a chemical formula and figuring out what the heck it's called. So this is way easier. So I showed you the hard stuff first. Now your life should be pretty simple. So all you got to do is you got to look up the names. So I look up the name of this ion. This is my positive ion, and this is my negative ion. So I look up the names. On my sheet, this is a polyatomic because it's more than one element. And I look it up, and oh, there we go. NH4 is ammonium. So I write down ammonium, and then I look at what this is, and this is chlorine. And I know that when chlorine is all by itself, all I need to do is add an IDE. So I put chloride, and your job is done. These ones are easy. But guess what? Of course, in science, we always make life difficult. And the difficult a little bit comes in with the transition metals. Because remember, in the name of a transition metal, there's always a Roman numeral. So when we write this into the word name, we have to make sure we put the correct Roman numeral there. So first things first, we just want to get it all written out and figure out the Roman numeral later. PB is lead. So I write down lead, put some parentheses there because I know that has to go there. And the way you can figure out that this is a transition metal is, guess what you're going to have to do? Look at the periodic table. Look at your periodic table. You find out that lead is right here. Kind of a mixed up one, but we consider it a transition metal. So we have lead with a parentheses. And then we do continue now on to naming what the next part of this ion is. And we go from, when we look at what SO4 is, we just realize that it's a polyatomic ion. It's more than one element. So all we have to do is look it up on the sheet. So we look up on the sheet and it is called sulfate. Now the issue comes in when we do have transition metals, when we have parentheses, we have to figure out what this charge is on lead, because that's what we need to fill in this space here. So the first thing we want to look up is, what are the things that we know for sure the charges are? Well, we can easily look up what sulfate is on our polyatomic ion chart, and it just so happens that sulfate tends to be 2-. Okay? This one is probably one of the more trickier ones that you're going to have to do, but not hard enough for that you can't figure it out. So if I have 2 sulfates and it has a charge of 2-, what would be the total charge of this section right here of the compound? It would be -4. Well, what I can look at is, okay, I only have 1 lead atom, so what does the charge on lead have to be to cancel out with the -4? It has to be +4. So then I just transfer that 4 down into my parentheses, and remember the way that I write 4 in Roman numerals is IV. So I have lead 4 sulfate, and that's well, there's your answer. I hope that this video helped you and that you're able to work through the problems on the sheet. If you have problems, if you continue to have problems, ask a friend, ask someone else, look up some other videos on YouTube. That usually helps. See what it's like for another teacher to explain it. Otherwise, I hope you have a great week. I will see you Thursday, and good luck. Bye.